What's going on, everybody? Let's talk about finding the equation of a tangent line to a given function at a specified point. So finding the equation of a tangent line to this function or this function at these points, x is equal to pi over 2 or x is equal to 2. Okay? Anytime you're asked to find the equation of a line, asked to find the equation of a tangent line or anything similar, you should think of three things that you need, which are listed here. You're going to need a set of coordinates, right? And a single set will do. So a single x and y coordinate. You're going to need also the slope, right? Or m value at your specified point. And once you have these three values, all you're going to do is plug it into the point slope formula. And if you forgot, it looks like this. Y minus y1 is equal to m times the quantity x minus x1, where m is your slope, right? x1 and y1 are represented by your set of coordinates, okay? Once you get that filled in, you can simplify it to get into the format that you probably recognize best. Y is equal to mx plus b, where m is your slope and b is your y-intercept, okay? And so let's work through these examples and we'll probably understand it a bit better, okay? So number one, find the equation of the tangent line to the function 2 plus 3 cosine of x at x is equal to pi over 2. So point number one, you need a complete coordinate set, and you're actually already given your x value, right? And that goes for these two as well. You're already given your value of x, so all you got to do is solve for your value of y. And like we said, your function, right, is written in this format, and f of x and y are interchangeable. So if I were just to rewrite this equation, this would mean the exact same thing. And by replacing f of x with y, you see that now you can just plug in your given value of x into this equation and solving for your y coordinate. So let's do that. Y is equal to 2 plus 3 cosine of pi over 2, okay? And if you have a unit circle, you're going to know that the cosine of pi over 2 is equal to 0. So 3 times 0 is 0. So y is going to be equal to 2 plus 0, which equals 2, right? So now you have your complete set of coordinates. Your coordinate is going to be pi over 2, 2, right? So item number one, complete. Now you need to find the slope, right, of this function or the tangent line at pi over 2. The derivative should come to mind because the derivative of a function is going to represent the slope, right? The rate of change, okay? And so to find our slope, we need to take the derivative, in this case, with respect to x, right? The derivative of our function, 2 plus 3 cosine of x, and we already know to take the derivative of each term inside of there. And so the derivative of 2, our first term, is a constant, and the derivative of any constant is 0, okay? Plus the derivative of 3 cosine of x, okay? And just to specify or refresh, if you're doing this, right, in your head, you should be remembering that anytime you have a coefficient or a number out in front of your variable of choice, right, you can always take this and move it out in front of the derivative. So this actually becomes 0 plus 3 times the derivative of just cosine of x. Okay? This is a constant, so you can just move it out. So now the derivative of this whole thing, let's continue this thing up here, is going to be equal to negative 3 sine of x, right? Because the derivative of cosine is negative sine. So 3 times negative sine of x is negative 3 sine. Okay? Now that you have your derivative function, right, you're going to, and let me just write this, right? So this is your derivative function. Now we need to assess at x is equal to pi over 2 because we want the slope at pi over 2, okay? And so f prime of x at pi over 2 is equal to negative 3 times sine of pi over 2. And we know that sine of pi over 2 is equal to 1. So negative 3 times 1 is negative 3, right? And so now we know that our slope is negative 3. And sorry if I jumped there really quickly, right? This is equal to negative 3, right? And this represents the slope, which is why I wrote this, okay? So now we have our x and y coordinate. We have our slope. Now all we got to do is put it into the point slope formula, okay? So let's do that. So let's do y minus our y coordinate 2 is equal to m, right, our slope, negative 3, times x minus our x coordinate, pi over 2. Right? So now all we got to do is distribute this negative 3 and simplify to get it in this form. So now we're going to get y minus 2 is equal to negative 3x plus 3 pi over 2. Move 2 to the right-hand side, and we're going to get this. Y is equal to negative 3x plus 3 pi over 2 plus 2. Okay? And you guys can combine these two terms if you'd like. I'm just going to leave it like it is here. Okay? So now let's try our second example. And feel free to pause and try it on your own if you'd like. If not, let's continue working together on it. Okay? So find the equation of the tangent line to this function at x is equal to 2. And again, we're already given our x coordinate. So all we need is to solve for our y. F of x and y are interchangeable, so we can rewrite our function like so, right? These are the same, and so now you can just plug in x is equal to 2, so you can solve for your y coordinate. So now you have 2 cubed is 8, so negative 8 plus 2 times 2 is 4 minus 2. So now you're going to have negative 4 minus 2 is negative 6. So y is equal to negative 6. You got your x value and your y value. Now let's solve for our slope, right? Step number 2. The derivative of this function, right, evaluated at x is equal to 2 is going to represent our slope at x is equal to 2. Okay, so let's do that. And let's do this here so that I'm more wary with the space. So the derivative with respect to x, right, of f of x, this is equal to this derivative right here, x minus 2, right? And we just have to apply the derivative to all 3 terms in here separately. So the derivative of the first term is going to be negative 3x squared, because 3 times negative 1 is negative 3. Leave the x there, subtract 1 from the exponent, you get 2, okay? Derivative of the first term done, add that to the derivative of the second term, which is just 2, right? Because 1 times 2 is 2. When you subtract 1, this is x to the 0. Anything to the 0 is 1. So this is done. Minus the derivative of 2. 2 is a constant. The derivative of any constant is 0, okay? So this is finished, and this is our derivative function, right? Now to find the slope at x is equal to 2, we're just going to plug in x is equal to 2. So we'll plug in x is equal to 2 into our derivative. And so this becomes 2 squared is 4. 4 times negative 3 is negative 12. Negative 12 plus 2 is negative 10, right? And this represents our slope. So now we have our x, our y, and our slope, right? All we gotta do is plug it into our point slope. So now let's do that. So this becomes y minus y1 is negative 6. So I'll leave that like so. It's equal to our slope, which is negative 10, times x minus our x value, 2. Now all you have to do is distribute this negative 10. Careful of your negatives, right? And then we will simplify and put it into this form. So we have currently y plus 6 is equal to negative 10x plus 20, because negative 10 times negative 2, okay? Move 6 to the other side, you're going to get plus 14. All right. This is done. Okay. Now our last example, and feel free again to stop and try it on your own if you'd like. If not, we'll continue together. And so the equation of the tangent line to this function at x is equal to pi. And again, right, x is given, f of x and y are interchangeable. So rewrite your function like so and plug in your x value to get your y coordinate. Okay. So y is equal to 3 times the sine of pi minus 2. Sine of pi is 0 if you look on any unit circle. So 0 times 3 is 0 minus 2. Y is equal to -2. All right. Now you have your x. You got your y. Now you need your slope. Okay. Step 2. So the derivative with respect to x, right? X of your function is going to be equal to the derivative of this stuff. 3 sine of x minus 2. Apply the derivative to both terms in here. This is the derivative of 3 sine x, which is, right, same thing as 3 times the derivative of sine of x, right? The same trick we talked about before, moving this out in front, right? Minus the derivative of 2, okay? All I did was write this step out, okay? So now we get 3 cosine of x minus, this is a derivative of a constant, which is 0. So now this is our derivative function. I'm going to go ahead and erase this part just for the sake of space. And so the cosine, all we got to do is plug in x is equal to pi, right? And we know that cosine of pi is -1. So -1 times 3 is -3. And this ends up being our slope. So now you got your x, your y, your slope. Now just put it into your point slope formula, okay? So y minus y1 is our y coordinate, -2, is equal to our slope, right? -3 times x minus our x coordinate, which is pi. All you have to do is solve this, right? Distribute to 3, careful of the negative. And then we'll get it into our format. So this becomes y plus 2 is equal to -3x plus 3 pi, because -3 times -pi, subtract 2 to the other side. Y is equal to -3x, almost missed that, plus 3 pi minus 2, okay? And you can feel free to combine these last two if you want, but I'm gonna leave it, okay? So I hope this made sense. If you got it, then good job. If not, it's totally fine, take your time, okay? So if you have any questions or concerns or comments, please leave them below and I'll get back to you as soon as I can, okay? Have a nice day, everyone.